In this example, we will find all solutions for cosine of x times cosecant of x times cotangent of x is equal to 6 minus cotangent squared of x, and we're going to keep all answers exact. Note that this problem says to find all solutions, which means our final answer should be a set of infinite solutions for anywhere where this equivalence holds. Now, if I want to approach this problem, I see a lot of trigonometric functions, and one of my first goals should be to try to get this to all be the same trig function if possible. Some identities I'm already thinking about because I see a cotangent squared term of x. I may be thinking about one of the Pythagorean identities. That Pythagorean identity being 1 plus cotangent squared of x is equal to cosecant squared of x. Or cotangent squared of x equals cosecant squared of x minus 1. Now again, that's what I would be thinking about initially because I do see a trigonometric term taken to a second power, so that is something that I can maybe apply. However, if I tried to do that, what I would get is 6 minus cosecant squared of x minus 1. And that still equals all these other terms on the left side here. Now again, I can do that, but that doesn't necessarily mean it's always going to help. In this case, I still now have a trig term taken to a second power. And I have 3 different terms on the left side there. So it doesn't seem like using a Pythagorean identity there helped to really make this into just one trigonometric function. And that's fine. You can always have trial and error there. So it doesn't seem like that's going to help much. On that left side, though, if I do try to manipulate that, I don't have many identities that involve cosine times cosecant, cosine times cotangent, or cosecant times cotangent. I don't have anything that I can really maybe pair a couple of those with. So at this point, I'm a bit out of a loss, and what I can maybe do, since I've run out of options, is try to replace everything with sine and cosine. It's not always a recommended thing to do in all circumstances, but when it seems like there's not much else that can be done, that maybe may reveal some other answers. For example here, if I take that left side and I replace everything there with values of sine and cosine. Well, the first term there is already a cosine, so I'm just going to keep that as it is. So cosine of x, cosecant of x, and cotangent of x. I'll keep cosine of x as it is. But cosecant of x I should be able to write as, using the reciprocal identity, 1 over sine of x. So I now have cosine times 1 over sine of x. I can also, with the cotangent of x, I could use a reciprocal, but that would make it 1 over tangent. Instead, I could use a quotient identity for cotangent to make this times cosine of x over sine of x. For now, I'm keeping the right side there as it is. Just focusing on the left, seeing what I can do with that. Well, then at this time, I see 3 terms that I can multiply through. I can multiply cosine times 1 times cosine. You can think about that first term as a fraction over 1. But I can multiply the numerators there. Cosine times 1 times cosine would give me cosine squared of x. And then the denominator, 1 technically, times sine of x would be sine squared of x. And this, looking at it, well, we had just used that cotangent is cosine over sine. Now I have cosine squared over sine squared. That, again using a quotient identity, is cotangent squared of x. So it seems to be pretty nice that I didn't touch that other side, as I can now relate that with 6 minus cotangent squared of x. If you happen to have changed the other side, though, into cosine squared over sine squared of x, you'll probably come to the same conclusion here and be able to go back. At this point, I can add the cotangent squared on the right side over to the left to get 2 cotangent squared of x equals 6. Divide by 2 to get cotangent squared of x equals 3. And then take a square root to get cotangent of x equals the square root of 3, as well as, remember, cotangent of x equals the negative square root of 3. All right. Now I just need to solve for x. We're finding all solutions, so my final answer should be the infinite set of solutions, so I don't need to find individual ones. Let's start with cotangent of x equals square root of 3. Probably don't need that much room. Okay, but cotangent of x equals square root of 3. Now that actually is a ratio that I am familiar with from the unit circle. We should be familiar with tangent and cotangent, ratios of 0, 1, square root of 3, and square root of 3 divided by 3. If you do have trouble with that, keep in mind that cotangent of x equals square root of 3. You can think about, again, the quotient identity of cotangent that implies cosine of x over sine of x equals square root of 3. Otherwise known as square root of 3 over 1 if I want to try to connect it more directly with that fraction of cosine over sine. And even more directly, I can divide both the numerator and denominator there by 2. So that now I can connect cosine of x equals square root of 3 over 2 and sine of x equals 1/2. That is why it is an angle measure that I am familiar with from the unit circle. Cosine equals square root of 3 over 2 and sine equals 1/2 at the same place, and that happens in quadrant 1 at pi over 6. Now cotangent, since we were working with a cotangent function, when we make the infinite set of solutions with cotangent, instead of making 2 lines, we can just take the first set and say plus pi k, as the other case where cotangent would equal a positive square root of 3 would be in quadrant 3, pi away from our answer in quadrant 1. So that would be our set of solutions there. If you even think about that in quadrant 3, that would be 7 pi over 6. That is where cosine equals negative root 3 over 2, and sine is negative 1/2. So the ratio there is still root 3 over 1. When I have cotangent of x equals negative square root of 3, well, that is the same application here. Keep in mind that technically when you use an inverse cotangent function, this will have to give you an answer between 0 and pi. Because that's negative, that should be in quadrant 2, between pi halves and pi. The one that I should know for that in quadrant 2, because it's the same ratio of square root of 3, that should be 5 pi over 6. And again, plus pi k. So that would be the set of all solutions here.